All right, welcome to the Explainer. Today we're doing something really cool. We're going to build a smart home, but not with wires and sensors. We're building it with code. And you'll get to see how some really clever features in Kotlin can take something that sounds super complex and make it, well, beautiful and easy to handle.
You know, we've all done it, right? Hey, turn on the lights. But have you ever stopped to think about what's actually happening under the hood? What's the code that makes that magic work? Well, that's exactly what we're going to do. Let's pull back the curtain and see what's really going on.
Okay, so just like building a real house, you've got to start with a solid blueprint. For our smart home, that means we need to lay down the foundation first, and we're going to start with the most basic building block of the whole system.
So, what is a smart home really? When you boil it all down, it's just a bunch of things connected together. In our code, every single one of those things, whether it's a light, a fan, a camera, you name it, it all starts as a smart device class. You can kind of think of it like the digital DNA for everything we're about to control.
All right, foundation's in place. Now let's get into the fun part. We're going to start defining what actually makes these devices smart. You know, their properties, their states, and, this is key, how we can manage all of that without our code becoming a total mess.
Okay, right away we hit our first little puzzle. Think about a smart light. It can be on, it can be off, and maybe, just maybe, it can have an error. That's it. There are no other options. So how do we write code that knows this? How do we lock it down so you can't accidentally set a light to, I don't know, purple when it should only be on or off? We need to be strict about this.
And this is where Kotlin just shines. It has this incredibly elegant tool for exactly this problem, and it's called a sealed class. The name is perfect because that's what it does. It seals off the possibilities. It's like a VIP list for your code. It says, hey, these are the only types that are allowed in here, and you have to define them all right there in one file, no exceptions.
And here's why that is so powerful. Because it's a sealed list, the compiler knows every single possible state your device can be in. So when you write your code to handle those states, the compiler can actually check your work. It forces you to handle every single case: on, off, error. That means no more surprise states, no weird else branches. It just massively cuts down on bugs. It's a game changer.
All right, next problem. We've got the state sorted out, but what about the type of device itself? We're going to have lights, fans, cameras, and again, that's a fixed list. We know what they are. So what's a clean way to represent that in our code?
For this job, Kotlin has another perfect tool, the enum class. You've probably seen these before. It's just a super simple way to define a group of constants. So we can create a device type enum and list out our options: light, fan, camera. Boom, done. It makes the code so much easier to read. And again, it's totally type safe.
And just to add the finishing touches to our device definitions, we're going to grab a couple more handy tools from Kotlin's toolbox. We'll use a value class for things like unique IDs. It's super lightweight and efficient. And we'll use a data class to hold configuration settings. They're just simple, specialized tools that make our code way clearer.
Okay, our devices are fully defined. They have states, they have types, they're ready to go. Now it's time to build the brains of this whole operation. We're talking about the controllers and the central hub that's going to manage everything.
So here's a question that every programmer faces at some point. Turning on a light and turning on a fan, they're kind of the same action, right? You're just changing a state. We definitely don't want to write the exact same logic over and over again for every device. That would be a complete nightmare to maintain.
And the classic solution to this is the abstract class. It's basically a blueprint, a template. Our controller abstract class is going to say, okay, every controller in the system must have a control method. It lays down the law, but it doesn't actually do the work itself. It just provides the structure and leaves the specific details to the other classes.
And this is what that looks like. We create a light controller and a fan controller. See how they both inherit from that main controller? They're both following the blueprint. They both have a control method, but the logic inside that method is specific to either a light or a fan. We get to share the structure, but we don't have to copy-paste any code. It's clean.
Now, this next part is absolutely crucial. Every smart home needs one central command center, a single source of truth that knows about every single device. You can't have two of them or three of them. That would be chaos. You need one, and only one. Now, in a lot of languages, creating this kind of one and only one object, it's called a singleton, can be kind of tricky. But in Kotlin, it's ridiculously easy. You just use the keyword object. That's it. We declare object Smart Hub, and Kotlin itself guarantees that there will only ever be one of these, and we can access it from anywhere. So simple, so powerful.
Okay, the moment of truth. We've built all these amazing specialized little pieces. Now let's see them work together. We're going to jump into the main function and actually flip the switch on our smart home.
So let's walk through what happens. First, we create our actual devices, a bedroom light and a ceiling fan. Then we create the controllers for them, the light controller and the fan controller. Step 3, we connect them to our single Smart Hub. Now for the action. We use the controllers to send commands. Let's turn the light on and the fan off. And for the grand finale, we ask the Smart Hub, hey, what's the status of everything? See, it's just a clean, logical sequence of events.
And that right there, that's the whole point of this design. Look at what we did. Instead of one giant monster class that does everything, we've built a really powerful system out of a bunch of small, focused, specialized parts that all work together beautifully. And hey, just to wrap this all up, here's a handy little summary. This table literally connects every single Kotlin concept we talked about to the exact file where we used it. You can see the sealed class for device state, the object for our Smart Hub. It's a perfect little map of the whole system we just built.
So, there you go. We literally just built a smart home from scratch, all in code. And hopefully, you saw how Kotlin's features aren't just fancy tricks. They actually guide you towards a cleaner, more powerful, and way more logical design. It's all about using the right tool for the right job. So we've laid out the blueprint. The question is, what would you build with these tools?